Okay, so in this video I'm going to do two more examples of finding the components of a vector when we're given the magnitude of the vector as well as an angle related to the vector. So in our first example here, we've got a vector that has magnitude 10 root 2. So I'm just going to make a little triangle that has length, the hypotenuse will have length 10 square root of 2. Okay, we're given that this angle is just 45 degrees. Again, I want to figure out the value for x and the value for y. Alright, well, again, we can do the same things before. So cosine of 45 degrees. So cosine is going to be the adjacent over the hypotenuse. So in this case, to solve for x, we can just multiply both sides by 10 times the square root of 2. So we'll get 10 root 2 times cosine of 45 degrees. That's going to give us our value for x. Well, cosine of 45 degrees, that's square root of 2 over 2. So we can do a couple things at once. Let's see, if we take 10 and divide it by 2, that'll give us 5. So that kind of reduces those. The square root of 2 times the square root of 2 is just going to give us 2. So our x value for our triangle would be 10. Now be careful, if you go back to our original picture here, right, x is clearly going to be a negative value in this case since we're going to the left. So our first component, we wouldn't want to use positive 10, we would have to use, well, negative 10 in this case. So just really based on what quadrant the vector is pointing at. You know, I use that to dictate whether I should be using positives or negatives. So the same thing to figure out y, we can just use sine of 45 degrees. So that'll be opposite over hypotenuse, so y over 10 times the root 2. You can do the same thing. Multiply both sides by 10 times the square root of 2. So we'll get 10 root 2 times sine of 45 degrees equals y. But recall that sine of 45 degrees is also root 2 over 2. So we're getting the exact same value that we had over here. So at the end, we'll get that y also is going to equal 10. Okay, and again, this to me, I'm kind of thinking about lengths of triangles. Well, if we go back to our diagram here, well, clearly the y component should be positive, so we will use positive 10. So again, you know, I kind of interpret these components. It says if you kind of think where it starts, if you move 10 units to the left and 10 units up, that's where the vector is going to stop at. So those would be the components for our first vector. We can do the same thing here for our other example. Might need a calculator on this one. But let's do the same thing here. So again, we've got a vector with magnitude of 14 and an angle of 65 degrees. So here's the magnitude of 14. Here's our angle of 65 degrees. Again, we're trying to figure out the value for x and the value for y. So we can do the same thing. Cosine of 65 degrees. That's going to equal, so cosine again is adjacent over hypotenuse. We can multiply both sides by 14, so we'll get 14 times the cosine of 65 degrees. Let's see here, cosine is 65 degrees, that's not one that I know off the top of my head. We could always use, I guess, a half angle identity, but let's just go ahead and plug it into a calculator. So cosine of 65 degrees, I'm getting that to be 0.423 after rounding. So 0.423, if we multiply that by 14, we'll get that x equals 5.922. Let's see, maybe we couldn't use a half angle identity now that I think about it. I'm sure we could be clever and deduce this using some half angle and double angle identities though. So same thing, to figure out the y coordinate, we'll just do, well, sine of 65 degrees, that's going to be y over 14. Okay, so sine is the opposite over the hypotenuse. Same thing, just multiply both sides by 14. So we'll get 14 times sine of 65 degrees. That will give us the value for y. Let's see, sine of 65 degrees, I'm getting that to be, let's see, 0.906. So if we take 0.906 and multiply that by 14, it looks like we'll get 12.684 as the value for y. Okay, so now I'm just going to go back and think about, well, what quadrant my vector was in. Well, our quadrant is down here in, our vector is down here in quadrant 3. Certainly the x component, the first component, should be negative. The second component should also be negative. X was 5.922, so we'll do negative 5.922. The y coordinate was also negative 12.684. Let's rewrite that a little bigger. So that's all there is to it. I'm basically just using a little bit of trigonometry to set up my right triangles to figure out the value for x and y, and then I'm just thinking about, again, the quadrant that the vector's in, and that again dictates whether the first and second component are positive or negative.